All right, so selective breeding is the process of choosing organisms with specific desired traits. I want to look at those two adjectives. Specific is going to be the color of the organism, the size of the organism. It's very specific, not just I like turtles or I like pine trees or I like, but like I like the leaves on that pine tree. I like the shell on that turtle. I like the characteristic or how nice that animal is or how friendly it is or how vicious it is. Specific trait, and it is a desired trait. So you can desire. I mean, I could desire an opposite trait that you desire, but it's still a specific desired trait. So selective breeding is a process of choosing organisms with specific desired traits to be the parents in the hope, and it doesn't say this on there, but in the hope that the offspring will also have those traits. And if we understand genetics, which we've been looking at, you can have a reasonable expectation that traits will be passed from parent to offspring. Now, does it always happen? No, but there's a certain amount of probability that you can look at a Punnett square with, and you can pass those on. Before people even understood what Punnett squares were, selective breeding has been happening. Selective breeding has been happening for hundreds and hundreds, even thousands of years. Selective breeding has been happening. So you can see on this next slide, there's a bunch of different traits. These dogs were not dogs that were in the woods one time and man said, hey, let's feed them and let them come inside. These dogs evolved or were selectively bred from a specific type of wolf or fox or something like it. Is a canine. A lot of the breeds that we see are coming from wolves. And we'll watch a little video that talks about, the title of it is, And Man Created Dog. It's kind of a play on words that in Genesis it talks about, and God created man. In his own image. The title of the movie is And Man Created Dog, because dogs were once far off, not very friendly to humans. And over time, humans and dogs interacted to the point to where now they are what we would consider a lot of times man's best friend. Corn was not a natural thing that is selectively bred. Tomatoes, potatoes, a bunch of the fruit and the vegetables that we eat, even animals that we eat, they are not natural animals. You don't go out in the woods. You've never seen like a wild cow. You've never seen a wild chicken. That just does not happen. So these animals have been selectively bred. All right, so let's read the slide. It says thousands of years of selective breeding has resulted in many of the vegetables we grow and we eat today. Cauliflower, cabbage, broccoli, corn, potatoes, tomatoes. There's a bunch of fruits and vegetables that have a natural ancestor, but humans have selectively bred better and better and better and better varieties, or even subspecies or species. So, for example, the wild mustard. Imagine that you are a caveman a long time ago, not an actual caveman, but you're, thousands of years ago, you were in your village and you're collecting leaves from a wild mustard seed, a wild mustard plant. And so you like the taste of the wild mustard plants, the leaves. And so you're out there, you walk a mile or two to where there's this really big field with a bunch of wild mustard in it, and you're collecting leaves. Are you going to collect the leaves of the plant that are larger or smaller? Probably larger because it's less picking. Let's say instead of just pulling the leaves, you just pull the whole plant up. You grab the whole plant instead of having to separate it out there. You just bring it home, and you're going to do that. So you're going to probably pick. I'm just guessing, and this is just a made-up scenario in Mr. Hurley's head, but you're probably going to pick the plants with the larger leaves on them. Now, when you get back, you're only eating the leaves. What are you going to do with the seeds that are on the plant, the stems and stuff like that? You might just throw it in and we can see in archaeological studies, we can see where there's like waste piles. Like they have like a garbage dump essentially, where you find bones of animals that were unused, or clay pots and dishes and stuff that were broken. There's like a trash area. So imagine you just go, or you send it with your kid because you're an adult, you're whatever. You send it with your kid. Hey, run this off to the trash pile. Instead of running it to the trash pile, they just throw it to the woods nearby, right on the edge. Well, next year, maybe the seeds from that mustard seed that had really large leaves, maybe they're growing this year. I'm sorry, the next year. They're growing. Now it's 1 year later. You're now seeing plants that your child disobediently threw next to the woods. Now, are you going to walk 2 miles away for a mixture of small and large leaves? Or are you going to walk a couple hundred yards away or a couple hundred feet away and pick up the plants that already have large leaves because they are the offspring from the large-leaved plants from last year. Which one are you going to do? You're going to walk right next door, right? Do y'all understand the situation? Imagine that happens over and over and over before anybody realizes, before you or any of your friends or family members realize that you could take the seeds from those and plant them in an area and water them and put some, what would be fertilizer down, like, dead animals or maybe the insides of an animal that you don't want to eat as fertilizer. Instead of doing, and before you even get to doing that, just by accident, some of these things might have happened before somebody realized, hey, that's where my son or my daughter put those plants last year. And the seeds grew larger because, hey, they were larger leaves. Maybe if we take the seeds this year and we plant them again and again, we can make little rows out of them. Hey, if we water them, they do better. If we put the remains of other plants or animals there, it's kind of like it seems to be better. And maybe in the religion of that time, maybe you're sacrificing something to the corn god or to the mustard god, and they're pleased with your sacrifice, so they let your plants grow larger. These things are not out of these; they're not just a crazy thing that Mr. Hurley just thought of. These are possibilities that could have happened. And so what you see is the evolution or the selective breeding of plants like kohlrabi, which you guys may not know of, kale, cabbage, broccoli, cauliflower. They all have ancestors back to wild mustard. And it's because a group of people or a person or probably a group of people over generations, they liked the leaves and they kept selectively breeding for large leaves over and over and over and over. And what happens every year as you're selecting for more and more larger and larger leaves? If you're selecting for large leaves, what happens every year? They're going to probably get bigger or at least more consistently large. Instead of having that small little runt every once in a while, the leaves are going to be consistently larger and larger and larger. And the same thing happens with all the different things. That's how corn started. If you look right here, can y'all read this word? It says teosinte. Say teosinte. So teosinte, look, it reminds me of bahia grass. Y'all know the little trident-looking things that looks like it has black ants all over the tip of it. I can show you guys a really mean magic trick one day. But teosinte, that's what it reminds me of. The little kernels. I don't know if y'all have ever seen the little things that are on there. But that's what it reminds me of. You can kind of see it in this picture next to the quarter. This is a quarter, so that's how large that was. This is the ancestor to corn. But over time, imagine Native Americans picking the larger one and the larger one and the larger one, and they're not going to pick the little runts. They're going to pick the larger seeds, and they plant them again next year and the next year and the next year. And eventually they end up with corn that looks much, much, much larger. It's not as large as this penny. Have you guys ever seen Indian corn? That's what I don't know if that's offensive, but I think that's what it's called. This corn that has a bunch of different colored corn kernels. It's not nice, big, fat, yellow corn that we have today. But the Native Americans provided a huge jump from this thing that looks like bahia grass, some weed with tiny, tiny, tiny little seeds that you wouldn't even consider a handful of it would not even be considered a snack. To what we have, what we as Europeans and Westerners got here, and we kind of hopped on that geneticist train and started selectively breeding even larger and larger and juicier corn. So the corn that you have today in the grocery store looks nothing like teosinte, but it does have an ancestor. That is its ancestor, and it got there through what process? Selective breeding. They chose one trait and they wanted to pass that on to the next thing. Every year, farmers save the seeds from the healthiest plants that produce the best food, and in the spring, farmers plant those seeds that are left over from the year before, and this cycle starts over and over. So way before we understood it to be genetics, things were getting better and better.